Today we are going to learn about related rates. So what are related rates? When frequently in trying to solve physical problems, we must establish a connection between the rates of change, aka derivatives. This connection is usually made by using implicit differentiation and the chain rule. For example, suppose that a spherical balloon is being inflated so that both its radius and its volume are related to the time by differentiable functions. Suppose that we want to know the relationship between the rates of change dv dt and dr dt at this specific instance. First, for any spherical balloon, there's a function which relates to the volume v to the radius r. And this function is the volume formula. V is equal to 4 divided by 3 times pi r cubed. Then we can differentiate implicitly with respect to t and use the chain rule to produce an equation which relates to the derivatives dv dt and dr dt. Okay, so let's do it here. Suppose that y is equal to 5x squared minus 6x plus 2. You need to find dy dt when x is equal to 4, given that dx dt is equal to 2 when x is equal to 4. So what are you going to do? You're going to take the derivative implicitly of this one. So you have dy dt is going to be equal to the derivative of this. You know that it's going to be 10x, okay, dx dt. And then you take the derivative of this one, so it's going to be 6 dx dt. Okay? Now, what are you going to do? You are going to plug the values that you have. Okay? Before that, you will never plug values at the beginning. Okay? So now you can plug values. Okay? We can plug values. Okay? So the first thing that you need to do is always take the derivative. After that, everything is fair game. Okay, so you have the situation, so clearly you have x, you have dx dt, and so we can plug them in. Okay, so you have dy dt is going to be equal to 10 times 4 times 2 minus 6 times 2. Okay, when you do this operation, you know that this is going to be 80 minus 12. Okay, this is going to be 68. Okay, therefore, what do you know? Therefore, dy dt is equal to 68 when x is equal to 4. And that's it. Okay, so this is your first example. Let's move on to the second example. Okay, so the second example here, it says that a balloon is being inflated at a rate of 10 pi feet cubed per second. At what rate is the radius increasing when r is equal to 2 feet? Please note that the volume of the sphere is this one. Okay, so what are you going to do? I always organize it at the beginning, given that, so they are giving me some rate. In this situation, they are giving you dv dt. And they give you this crazy value that you have over there. That's okay, we can use it. Okay, so given this, you need to find, and they are telling you that you need to find another rate, dr dt. Okay, but they give you more information when r is equal to 2 feet. Okay, so this is what we want, what we have, what we want. Okay, now I need my main equation, which is going to be this one. Okay. So since it only has one variable, that the variable is r, I can take the derivative. So take the derivative of that one. You have that dv dt is going to be equal to what? Okay, so take the, you have a 4 divided by 3, so you have times 3 pi, okay, because you are bringing down the exponent, and then you are taking the derivative of dr dt. Okay, please remember that you have the chain rule, and the first thing that you're going to do is take the derivative. Once we have this situation, what we're going to do is you plug your value, so you have 10 pi is going to be equal to 4 divided by 3, and actually you can cancel them out. Okay, so I don't need them, pi, and then you have the r square, and then you are looking for dr dt. Okay, so what we're going to do here is I'm going to solve for dr dt. Okay, so once you have the situation, you have that your dr dt is going to be equal, and you can simply do this. Okay, we know that this is 16 pi. Okay, so a bunch of things cancel. So what do you have here? 5/8. Okay, feet per second. Okay, so that's going to be your dr dt. Okay, let's look at this problem. It says the top of a 15-foot long ladder rests against a vertical wall with the bottom of the ladder on the level ground. The ladder is sliding down the wall at a constant rate of 2 feet per second. At what rate in radians per second is the acute angle between the bottom of the ladder and the ground changing at the instant the bottom of the ladder is 9 feet from the base of the wall? Okay, so the first thing that you need to do is you need to label this as your angle. I'm going to name this one y and this one x. Okay, so what information do you have? Given, okay, dy dt, okay, you have that this is equal to -2 feet per second. And we know this because it's sliding down, okay? So you have this down, okay? They want you to find d theta dt, specifically when the bottom, aka this part, is equal to 9, so it's going to be x equals 9 feet. Once you have your information set, you're going to be like, oh, what's the relationship between x, y, and theta? And you're like, pre-calc and geometry. Okay, so what do you have? We have, okay, that sine of theta is equal to y/15. You are going to tell me why you are selecting sine. Well, in this case, what I'm thinking is I want dy dt. So if I take this derivative, I'm going to have, of course, d theta dt here, but I'm going to have a dy dt here. Okay, so I could select also cosine, but I'm going to have dx dt, which I don't have information about. So that's why I'm conveniently picking this guy. Now, you take the derivative of this one, and you have that it's cosine theta d theta dt, okay, because you have the chain rule. It's going to be equal to 1/15, okay, and then it's going to be dy dt, okay. Now you ask yourself, do I have information to plug here? And you're like, okay, I'm looking for the theta dt. I don't have cosine of theta apparently. I do have 1/15, and I do have this one. So what is cosine of theta? You know that cosine of theta, okay, specifically when x equals 9, you know that cosine of theta is x over hypotenuse, right? So you know that it's 9/15. Are we okay with that? At that specific moment in time. So what are you going to do? Plug it in, okay? So you have 9/15 d theta dt is going to be equal to 1/15, and then this one times -2, okay? Now you are going to pass this one to the other side, canceling the, let me put it here, d theta dt is going to be equal, these 15s they cancel, and then you have that this is going to be -2/9, and you know that this is going to be in radians per second, and that's the problem. Okay, that's it for this problem. Okay, so let's move on to the next one. Okay, over here you have that a fish is reeled in a rate of 2 feet per second from a bridge 16 feet above the water, and they give you the bridge over there. Okay, at what rate is the angle between the line and the water changing when there are 20 feet of the line out? Okay, so where's that angle? That angle, okay, basically is this one. Okay, so what do you have? Okay, I'm going to call this one x, that one is y, and let's call it this z. Okay, so what do you have? The fish reel. Okay, so given that dz dt is equal to what? at a rate of from the bridge above the water, so you are pulling it, so it's going to be negative, okay, feet per second. Okay, so we have that. They want you to find again your d theta dt, okay? Specifically when what? When the line, this one, okay, is 20 feet, when z equals 20 feet, okay? So that's what we have. Now, what are you going to do? Okay, so you have y is set, okay, and you have dz dt, so the one that it's convenient to use is this guy, okay? So do you want to use cosine? Absolutely not. Why not? I don't have any information of x, okay? So you want to use again, now this is your best friend, sine. Sine is going to be equal to 16 divided by z, okay? So once you have that, you take the derivative, okay? So you have that it's going to be cosine theta d theta dt is going to be equal to, what's going to be that one? It's going to be negative 16 divided by z squared dz dt, okay? So after this, you are like, okay, I already took the derivative. Okay, so what information do you have? I have z, I have dz dt, and the only thing that I'm missing is cosine of theta. Cosine of theta, okay, specifically when z is equal to, what was it, 20, you know that it's going to be equal to what? Well, you know that cosine is going to be equal to x over 20. What is x when this is 20? Well, you know that by Pythagorean triplets, that one is going to be 12. Okay, so by Pythagorean triplets, or you can do, you know, the good old way, so we know that x is equal to 12 feet. Okay, therefore you know that cosine of theta is equal to what was it, 12 over 20. Okay, so you plug it in. Okay, so I'm going to plug here. You have 12 over 20. Of course you can simplify it, but I was just like, no. Okay, so negative 16, and then you have that z is going to be 20 square, and this one is going to be negative 2. Okay, so over here we need to simplify, right? So you cancel this 20 with this one, okay, and you have that d theta dt is going to be equal to, this is going to be 32 divided by 12 times 20. Okay, so when you simplify this equation, you have that this is going to be d theta dt is going to be equal to over 15. Okay, and this one should be in radians per second.